Hello, viewers. You are welcome once again to episode number 7 on the trigonometry. In this episode, we want to deal with the various units into which angles are measured. Already, we know all the calculations we did so far from the first 6 episodes are based on degrees, but degrees are also subdivided into minutes, minutes subdivided into seconds, and some measurements are also in what? Radiant. So how do we maneuver ourselves from the degree back into radiant and radiant into what? Degree. So angle measure in degrees and what? Radiant. So let's take the radiant measure. We are already aware of the degree already. So a radian, which is the RAD, is defined as the measure of the central angle. A central angle is the angle whose vertex is in the center, subtended by the arc or an arc of a circle equal to the radius of the circle. So if I have this, as I'm seeing here, the length of AB is an arc. If I have another arc here, if I measure OA and the value I have is the same as the AB, then I can say that I am having the measure of radian. So the moment the length of the arc is of equal length of the radius of the circle, then the radian measure can be applied or is established. So you can see from here, the length is R, which is also having the same dimension as what? The radius. So that is the fair definition we can give to radian. Now, if you look at AB, there are a series of AB we can get. We can subdivide these lines into RRR. Now, when I'm dividing it, I am dividing the circumference. So I can divide the circumference further into various arcs to see how many of the radiant or how many of these R can be found on this, not just by marking, but by measurement. So if I'm looking for that, the number of radiant that I'll get if I divide the circumference in one complete resolution, meaning in a full term as we are having, is given by the ratio. We need to find the circumference of the circle, which I mentioned earlier on. If I'm dividing this into pieces, I'm dividing the circumference into the R. Good. Then it's a ratio, so we divide it by, what are we dividing? We are dividing the length here. This length we are using is the arc length, which is also the same as the radius we established by the definition here. The length of the arc, which is still the same as the radius. So I'll just say length of each word, radius, right, is a ratio. So to know the number of radians that will be established there or can be found in any circle that have an arc being equal to the radius. Now, how do we find the circumference of a circle? By formula. We know the circumference of a circle is 2 pi what? R. Then the length of the radius is going to be R. And that will give us pi what? 2 pi. The radius will cancel radius, giving us only what? 2 pi. But what are we looking for? We're looking for the number of radians. So this 2 pi is going to be in radian. I guess that is clear. So this is what we are using to represent the number of radians we are going to get. So if it is 1, 2, 3, this is the value. Now, we mentioned that it is done in what? One complete resolution. Under angle measurement in degree, when we mention one complete resolution, we are referring to all angles in a circle, which is what? 360. So we can say that in one complete resolution, we already know that a total angle in degree is what? 360. And this is also the total number of radiant angles we can get in radiant. So this will also be equals what? 2 pi what? Value. So this is in degree, total angle, the complete resolution. This is the angle you get. In a complete resolution, this is the angle you get in what? Radiant. Right? So if I divide both sides by these two to make the pi the subject, I'll be having here to be 180 degree equals what? Pi. That really means that 1 pi is equals to what? 180. That 180 is equal to pi in terms of measurement and angles, not in a real sense, which we know is the ratio of the diameter and that of the circumference is different compared to this. So now what do we do? If I am looking for the value of what? Radiant. Let's say I want the radiant. If I divide both sides by pi, I should be left with 1 here, meaning 1 radiant will be equal to this. Or if I divide this side by 180, I should be left with 1 degree equals to pi on what? 180 degrees. So it means that if I want to change from degree into radiant, this is the convection. 1 degree equals to pi on 180. So 2 degree will be 2 times this, right? So 30 degrees will be this multiplied by what? 30. 60 degrees, this by the value. I guess you are getting it. So right here, I think you can be able to get the connection or the relationship. So 1 degree equals to pi on 180 rad or radius, right? The same way, if I divide this by pi, I should be having 1 rad or radiant also equals to this divided by pi. This 180 degrees divided by what? Pi. So from here, I move to this by the multiplication. Here, I move to this by multiplying by this. So let's see what will be the relation in terms of formula if I'm looking for. Without finding the generalized formula, you can still work with this. 1 degree is equal to pi on 180. So if the degree increases, this will be increasing by that multiplication, that multiplier. If 1 rad, right, is equal to this value, then it means that if the rad increases, it will be multiplied by this. So let's get that relation as a generalized formula which we can use in calculation. Or better still, you can stick to this. Okay, so to get the relationship between the radiant and degree, we are going to use theta for degree and use R, capital R for what? Radiant. So let's see if I am looking for a calculation in what? Radiant. What is it going to be? Remember what we did here? That if I have 1 degree is equals to the pi divided by what? 180. So if I'm also having 1 rand is equals to 180 divided by what? Pi. So now in this case, I need the radiant. So what do? I will be given an angle which will be in theta. So if I multiply this angle by the value, the unit value we had in the beginning, then our answer is going to be in what? Radiant. Then if I am looking for the theta, even from here, we can do our own change of subject. When this multiply this, you should be having this and this divided by pi. So if I'm looking for theta, that also means I multiply the radiant by 180 degree divided by what? Pi. And this will be in degree. So as we can see, I think I can put degree in here. Now check. This could also go behind and multiply. As this will go, we know multiplication is what? Commutative. So if I have example 1, we are to convert, let's say 30 degrees in radian. What should I do? This 30 degrees is representing this. So I'm looking for radian. So your solution become, your theta is the 360 degree. The R you are looking for is now 360 degrees from here times pi on what? 180 by just this formula. If you don't want to, we can still go back to the first instances we made. If 1 degree is pi on 180, then 30 of them by multiplication, you get your answer. So this is going to be, go here. So we have pi on what? 6, which will be in radiant. So radiant. So the value of 30 degrees in radiant is pi on 6. And this pi is not the 22/7 value we are picking from here. So this pi actually is referring to 180. So 180 divided by 6, you come back to what? 30. All right, let's see if you pick example 2. Let's say we have pi on 4. We are asked to convert into degree. So it means from here, your R is your pi on what? 4. You are looking for degree, which is this multiplying the conversion rate. So I'll be having pi on 4 multiplying. The next value, what do we have? It is 180 divided by what? Pi. And then the formula, right, from, 180 divided by pi. So that this pi will cancel this. Then I should be having 180. 2 can go here, 2 go into 180 90 times. So your answer should be 45 degree. So 45 degree is the same as pi on what? 4. I guess the convection, the steps taken is okay by you. You can try so many examples, moving from radian into degree and degree into what? Radian. Or let's see if we can try this. So let's look at these two. We are converting 2 pi on 3 into degree and 270 degrees into radians. So make use of the formula, or make use of the fact that 1 degree is equals to 180 pi over 180, and 1 rand equals to 180 over what? Pi. I guess we are cool. Share your answer in the comment section as we learn together. Share the video with somebody. Subscribe if we have not.